Alright, looks like we're live. Let me just double check. Yeah, we're live. Alright, I'm just gonna wait a couple minutes so that people log in. We'll get started. How's everybody doing? Good? Couple more minutes, so like that we can wait for whoever's gonna log on with us. Once again, if you have questions, just type them in and try to answer them as we go along. Also, if you want to get started, make sure you copy the warm-up 115 and get a Cornell note ready. And what else? I think that's it. How's everybody doing? Good? What's up, Chance? How you doing? How you doing, Vivo? I still don't know who Vivo is. But anyways, welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? All right. Let's go. So let's get started. Warm up 115, and it's the continuation that we started the other day. So it's rewrite each expression. Part A is 5 to the negative 2. Part B is 230 to the 0 power. Part C is 1/4 to the negative 2 power. Number 2 is if x to the third times x to the fifth equals to x to the 3 plus 5, which is x to the eighth, then rewrite 10 to the power of x minus 2. Number 3, f of x equals x cubed using the domain -2, -1, 0, 1, 2. Then transform the function given g of x equals parentheses x minus 5 close parentheses to the third power plus 3. And number 5, look at the figures below, find the pattern and write a rule. How many squares in the seventh figure? Notice that for number 1, they don't have any figures. Number 2, it looks like they have 3 squares. Number 3, they have 1, 2, 3, 4, 5, 6, 7, 8 squares. And number 4, they have 15 squares. See if you can find the pattern. So, Chance, I'm doing good. Good to hear you're doing good also. Isaac, how you doing? Fernanda, yay! How you doing? Good to see you. And hopefully it's going well, right? A lot of work at home. Washing dishes, vacuuming, washing the cars, right? Hey, you're building up a good piggy bank for later. Good. The playlist. Okay, so what happened is that what had happened. I still have my playlist. I'm trying to figure out another way of getting you guys the playlist, and I think I'm gonna do that via Google, maybe Classroom. I'm gonna send you guys a code so you guys can log in and just get it from there. And what happened is that I had Spotify, and I guess somebody was trying to hack into my program. It wasn't you, right, Vivo? Anyways, so I had to delete that program, and I also unregistered from that account. So maybe I'll try it again later on with a different email and go from there. But for right now, Like I said, I already have it. I just need to figure out how I'm going to give you the number one. Let's see. So for number one, if it has a negative exponent, we cannot leave it like that. This becomes 5 to the positive 2 in the denominator. We put a 1 on the numerator, so this is 1 to the 25th. Hopefully you got that, right? All right. 230 to the 0 power. Anything to the 0 power is always what? And that's right, 1. All right, part C. So here, there's an invisible 1 here, invisible 1 here as exponents. This exponent distributes to both numerator and denominator. So that means this is 1 to the negative 2 and 4 to the negative 2. I'm going to go this way. So which is, to change this into a positive, it goes to the numerator, this one to the denominator. So we end up with 4 squared over 1 squared, which is 16. And you probably saw your notes from last week, or I'm sorry, from last week or Tuesday, and you should have gotten that. All right, number 2. So 10 to the x minus 2 power. So it's 10 to the x times 10 to the negative 2. Is that correct? Yeah. And you're saying, why do you rewrite it like this, Mr. Q? Well, if these are the same base, that means we can write it as one base. And what happens to the exponents? We add them. That's why we write x plus negative 2 or x minus 2. So, however, we cannot leave this one with base 10 to the negative 2 power. That means the 10 to the negative 2 becomes 10 to the second power in the denominator. And over here we have 10 to the x. So that means we're left with 10 to the x over 100. Are we doing good? Good. All right. And this one, how does this one look? It's a cubic function. It should look something like this. You plotted your points 0, 0, negative 1, negative 1, 1, 1, negative 2, negative 8, and 2, 8. And what does this do to the entire function? It moves it 5 to the right and 3 up. 5 to the right and 3 up. So that would be our transformation. Yes, Isaac, but we're going to get to that later, so no worries. We'll talk about the quarter assessments later. Genesis. And here's my dog. Came to check up on me. All right, let's go to number 5. It says, look at the figures below, find a pattern and write a rule. How many squares in the 7th figure? So, if you remember from the previous ones that I gave you like this, what did we find out? What was happening to each of these as we were getting the next figure? So let's see. This is 4, and we were getting a square, weren't we? So let's see, so what did we do? So this was what, 4 squared, and it would give us 16. But what do you notice now? That it's missing what? Right? It's missing this one. How about this one? 3 squared, and it's missing what? This one. How about this one? 2 squared, and it's missing this one. Yeah, one of these days. So she's upstairs doing her study. So my bad. So let's go to this one. What do you guys notice? It's missing something. So think about it. If this was a rule, so then f of n equals to n. If it did have the square, what would we write? N to the what? That is correct, to the second. However, it's missing one of the squares, so what do we do? That's right, minus 1. And let's see, would it work for this? What is 1 squared? 1 minus 1, 0. That's why there's no square. 2 squared is 4 minus 1. That's 3 squares, all right? 3 squared, that's 9 minus 1. That's 8 squared. Oh yeah, it does work. So they want us to find the what? The 7th figure. 7th figure. So then we write f of 7 equals 7 squared minus 1. F of 7 equals 49 minus 1. So therefore, f of 7 equals 48. All right. All right. So, let's move on. So our home plate for today is on pages 661 and 662 only. All only. Pages 661 and 662 all only. And your near pot code is TIXCO. And once again, once you're done with the work, you can turn in your work there. TIXCO. All right. So we got this. Our objective for today, I can graph exponential functions. Once again, I can graph exponential functions. What is the main idea again for today? Yeah, exponential functions. We're still not done with those. So get a fair model going without looking at your notes. See if you can remember the definition of exponential functions. Give me one example, one non-example, and a hashtag. I'll give you some time. Man, this is good. Tastes like strawberry, but it's water. So, science. All right, you got it? Exponential functions. What are they? Well, exponential functions, we said it was a function written like this: f of x equals b to the x power, or we've been working with g of x equals a times b to the x minus h power, close parentheses, plus k, and b has to be greater than 0, and it cannot equal to 1, where x is a variable. And we're going to get into the negative ones, and you probably saw that already in the function form for Desmos that I gave you. I'm pretty sure you filled out your pit table already. Examples, non-examples, and hashtags. Function, hashtag base with positive number, not 1, and variable exponents. All right, let's move on. So just to revisit our general form of transformation rule, remember these: g of x equals a times f of parentheses 1 over bx minus h plus k. And we said if we apply that now to exponential functions, it looks something like this: g of x equals a parentheses b to the x minus h power plus k. And I asked you guys to do an activity with Desmos and fill out that table. You guys remember that? And by now you should have an idea as to what it does. But today we're going to just make sure that in case you haven't done the activity, that you know what each piece does, but focusing now just on exponential expressions, because I want to wrap this up and move on. So like that Tuesday when we come back, we move on to the next thing. Okay. All right. So just to recap, last week, because on Tuesday I gave you guys some more practice. Last week we started with this example, example 1, A, B, and C. And I noticed I gave you f of x equals base of 2 to the x power. And then B was g of x equals base of 2 to the x minus 1 power. And C was g of x equals base of 2 x to the minus 1 power, but then minus 5. And the parent function was this. We graphed it, and then we graphed this one. And for this one, we said from the parent function that it moved what? Hopefully you saw it. It moved one step to the right. That is correct. One step to the right. And this one, basically we took this function, the red one, and this one moved 5 steps which direction? Downward. That is correct. Downward. And if you notice, like all the transformations are still pretty much exactly the same as the other functions that we've done, right? All right, so today we're going to revisit one that we did last week, which is this one. So copy that one. Yes, copy it again, even though we already did this one last week. I want to make sure we revisit this one. So it says example 1 again, part A. It says graph g of x equals 1/3 to the x power. And today we're going to use domain from -2 to 2, and we're going to find g of x. Oh, I should have changed that to g of x right here. There it is. All right, copy that. Alright, so I'm going to zoom in so like that we can do the work right next to it. And for those of you that write with your feet, remember, try and write a little bit more legible, because this is like the pixelation of my tablet. Bam. So I'm going to do this one in blue. So I'm going to write 1/3 to the what power now? Because we're substituting in for x the -2. So what did we find out? That if we put a 1 here, distribute, this becomes 1 to the -2, 3 to the -2, which is 3 squared over 1 squared, because this goes to the numerator, this to the denominator to change the powers. You guys remember that? And this becomes 9 over 1, which is 9, and that goes right there. Alright, let's go to the next one. This one. 1/3 to the -1, 1 to the -1, 3 to the -1, which is 3 to the first, 1 to the first. What is 3 to the first? The number itself over 1, which is 3. Let's go to the next one. 1/3 to the 0 power. Any number to the 0 power is? That's right, 1. That goes right there. Alright, next one. 1/3 to the first power. Anything to the first power is what? The same number. So we get 1/3. That goes right there. Alright, next one. 1/3 to the second power, which is 1 to the second, 3 to the second, which is 1 over 9. Alright, so if we graph that, let me move over this way. -2, 9, -2, 9, which is right there. -1, 3, -1, 3, right there. 0, 1, 0, 1. 1 and 1/3, 1 and 1/3. Let me move this over, and 2 and 1/9. 1 and 1/3, 1 1/3, 2 1/9. Okay. Let me zoom out. Now, reminder, guys. Remember that we still need a asymptote. Does it have a constant here after the function given at the end? No, if it doesn't have a constant, so what is our asymptote? That is correct, 0. So, hold on, let me do this. Like this. There it is. Alright. So our asymptote, horizontal, oh my goodness. Our horizontal asymptote is y equals 0. That's why it goes through 0. Alright, so let's graph this from left to right, going through those points. Arrows at the end so that we know it continues going in those directions. Alright, are we doing up to right there? We're good, right? Okay. So negative 2, 9, negative 1, 3, 0, 1, 1, 1/3, 1, 1/9. So I don't know if you guys notice from the practice you did last week. Today we're going to notice something a little bit, common or pattern. I want you to pay close attention to these three values, negative 1, 0, and 1, and their output values. All right. Let's move on. On that same graph that you did, copy part B. G of x equals 1/3 to the power of x minus 1. All right, let me zoom in. Right there. All right, so let's do this one in red. So we got 1/3 x to the negative 1. So we got 1/3. What is x now? Negative 2. So we got negative 2 minus 1, parentheses. So this becomes, parentheses, 1/3 to the what? Negative 3. Distribute, distribute. That gives us 1 to the negative 3, 3 to the negative 3. So this, if we bring this one up, this one down, we got 3 to the third, 1 to the third. So this becomes 3 times 3 times 3, that's 27 over 1, which is 27. And that goes right there. All right, let's go to the next one. 1/3 to the negative 1 minus 1, negative 1 minus 1. And this is 1/3 to the negative 2. If we distribute to this one and this one, we get what? 1 to the negative 2, 3 to the negative 2, which is, bring this one up, this one down, so this is 3 to the second over 1 to the second, which is 9 over 1, which is 9. All right, next one, this one. Let's do 1/3, and we got 0 minus 1, which is 1/3 to the negative 1. Distribute, distribute. 1 to the negative 1, 3 to the negative 1, which is 3 to the first over 1 to the first, which is 3. That goes right there. Genesis. Hold on. All right, so let's go to the next one. Oh, sorry. We got 1/3 to the 1 minus 1, which is 1/3 to the 0, which is 1. And the last one, 1/3 2 minus 1, which is 1/3 to the 1 power, which is 1/3. All right. So let's graph that. Let me zoom out. Okay, let me get this out of the way. All right, so we got negative 2 to the 27, doesn't fit. Negative 1 to the 9th. 0, 3. 1, 1. 2 and 1/3. All right. And it continues going. And what do you guys notice? The horizontal asymptote doesn't have one, so once again it's going through here. Now let me graph the previous one, which was this one. And we said this was what? Negative 2, 9. Negative 1, 3. 0, 1. 1, 1/3. And 2 and 1/9. Let me graph that. Negative 2, 9. 1 3 0 1 1 1/3 and 2 1/9. Well, sorry. Oh my goodness. Sorry guys. A little bit of technical difficulties. Alright, there it is. Alright, by looking at those two, the original one, the parent function, and this one, what is the only thing you notice different from the function? Yeah, this one has a -1, this one does not. And what happened, if I was to ask you what happened, what transformation happened from here to here? Yeah, it moved what? One step to the right, each point. Notice this, one step in that direction. Piece of cake? I'm like, yeah, this is a piece of cake, Mr. Q. Alright, look at this part. You're going to do that by yourself, but look at it. So what do you notice? This one is the original function. What did this one do? And moved it to the right. Alright, so this one follows this function. So if this is, if you already know the graph for this one, tell your neighbor, whoever's watching with you, what happens now with this from here. Yeah, the asymptote is what? At +2, which means it moves everything up 2 steps. Now, if I was to ask you from the original parent function, what happens up to here? What would you say? Yeah, it moves 1 to the right and 2 up. That is correct. 1 to the right and 2 up. And pretty much that's going to be the home plate, guys. Just graphing, graphing, graphing. On Tuesday when we come back, we're going to do the writing of a function, and this time not given A and not given B. We're going to do the whole thing, and that's going to wrap it up. But that's pretty much it. So, and you'll finish that on your own. Let's wrap up this. So what did we see last week? I gave you guys a function that looked like this. And today we did a function that looked like this. Well, last week, these kind of exponential functions are known as growth functions. What are they called? That is correct, growth functions. And what does that function look like? It looks like this. And the asymptote would be right there. And what did we find out today? Today we did with these. These are called decay exponential functions. And they go from left to right. They go downward like so. And here's our asymptote. And of course, you know all the transformations that we can add an A, which is a number that would be our multiplier, or a constant that would move it to places, and we can add numbers here to the exponent here, and it moves it either left or right, and so on and so forth. So just so to make sure that we got it, these are growth, these are decay, and here are the asymptotes. In case you still haven't done the activity, once again, here's the Desmos code. You go to student.desmos.com, and the code is A2PK3E, and it doesn't have to be capitalized or spaced altogether. And once again, you can go in there, and you don't have to even log in with your Google account. You can actually go, don't want to log in, just type in your name and it should take you there. Alright, I'm also including in the Nearpod presentation, guys, I'm including a quizzes activity. Let's go. And see how you guys do with that. So make sure when you go to Nearpod, in there the code would be in there. and then once you go to the following, make sure you write that code. When you go to the following slide, make sure you start off by registering with that code, and then you put your period number. If you're in my period 2 or 3 or 4 or 1 or 6, just put the number and then your full name, so like that I know who's playing. And make sure you do that activity on Desmos. And our objective was I can graph exponential functions. Have we been doing that? Yeah. And you're like, Mr. Q, this is a piece of... I know, I get it. I just want to make sure you understand all the different pieces before we get into logarithms, which is going to be a funner stuff. I mean, it's just work, but it's funner. Okay? All right. So with that said, reminder, tomorrow's Friday. Make sure you wear red. Tiger red, let's go. And once again, a group of Imperial High teachers, we're going to get together. We're going to be cruising around just to go say hi through the neighborhoods. You don't have to come out. You can be in your window just waving to us. Don't do don't go to the corner, don't go out, and don't go get together with your neighbor. This is just so that you can hear us outside, that we're going to be cruising by, and we just want to say hi and to show you support that we're still doing our social distancing. That's why we're staying in our cars, windows rolled up, but at least you're going to hear us honk throughout your hood. And there's the list of the neighborhoods we're going to go to, and we're going to take about 5 to 10 minutes in each neighborhood, depending on how long it's going to take us to go around. But just I'll probably be looking to the windows of the homes or to the doors and see if I see you, and I'll just wave and honk and so on and so forth. All right. But remember, guys, keep at it. I mean, I know we're in a special situation, and things will get better. You'll see. I'm confident that you guys are doing all the best you can at home. You're being a blessing to your parents, and you are being proactive and washing dishes, cleaning the restroom, toilet, let's go, washing cars, exercising. Anybody exercising aside from your fingers and gaming and such? Come on, guys. But anyways, hopefully we're on track and everybody's following along. And once again, I'm going to leave the Nearpod code on, so like that you can turn in your work anytime you have it. All right. And once again, if you have any questions, just write it out in the pictures that you send me. And for those that are struggling sending in stuff on Nearpod, just take pictures of your notes and your home plate and email me. I mean, that should take care of that. Okay. And once again, if you are not part of my class and you still want to participate on the quizzes and all that, go ahead and log in and just say I'm from Mr. Pettyjohn, or I'm from Mr. Scott's class. Or if you're not even at our school and you're just following along, getting the extra practice, you can still participate. It's just a review. It's a fun game. So just log in and follow along. Okay. All right, guys. Well, 10Q. Bam. And like I always said, I mean, if you're not moving forward, then you're already behind. Okay? Bam, let's go from the corner. All right, guys. Well, see you guys on Tuesday. Love you guys. All right? See you guys Tuesday. Peace.